Okay, I want to explore the vector nature of velocity and acceleration and the relationships between those two quantities in more detail in this lesson. Now, when students are first learning about velocity and acceleration, they often get them confused, but these are two very different quantities. Remember, velocity is the change in position over time, and acceleration is the change in velocity over time. And being vectors, velocity and acceleration both have a magnitude, a direction, and a unit. Remember, there's also speed, which is a scalar. So I'm going to go through several examples of different types of motion, some motion diagrams with you. And we'll look at the relationship between velocity and acceleration for each of these, and the speed. So what I've drawn is a series of pictures with a poorly drawn car that's undergoing some different types of motion. And let's just look at this first case, situation A. Notice I've drawn a coordinate system that has its positive direction going to the right. And I've drawn the location of this car, the position of the car, at equally spaced time intervals. So imagine there's a strobe light flashing at equal time intervals and you see where the car is. Or you just take a picture of the car at equally spaced time intervals. So what's happening in this first picture is that the car is moving at a constant velocity. Its speed stays the same, its direction stays the same. So for picture A, if I draw the velocity vectors for the car at each instant in time, those velocity vectors all look the same. So these vectors represent the car's speed and direction. The length of this arrow is the speed, and the direction the arrow is pointing in is the direction of the velocity. So for each situation here, the car has the same speed and the same direction. Its velocity is not changing. So that means that its acceleration is 0 the whole time. It's moving at constant velocity. Now in picture B, we have the same coordinate system where x is positive to the right, and I've drawn the car at equally spaced time intervals. Now notice that the car is getting farther and farther away each time. That means its speed is increasing. So its velocity is still going to the right the whole time. So I could draw its velocity vectors as getting bigger and bigger, but still pointing to the right the whole time. Now, because the velocity is changing, that means there must be an acceleration. And that acceleration is a constant value. The acceleration of the car at each instant in time is the same length, and it's pointing to the right. Now, in the last lecture I mentioned that when velocity and acceleration point in the same direction, the object speeds up. So this car was speeding up, it's getting faster and faster. So if its velocity vector is directed to the right, that must mean that its acceleration vector points in that same direction. So positive acceleration is referring to the direction it points in. Remember, positive and negative in physics correspond to directions. So because velocity is pointing in positive x, acceleration is pointing in positive x, they point the same way and the car speeds up. In situation C, things are different. The car is slowing down. It's traveling less distance. It's undergoing less displacement. as time goes on. So if we draw its velocity vectors, it starts out fast. It has a big velocity pointing to the right, but if you put on the brakes, and that velocity vector gets smaller and smaller. Because the car is slowing down, that must mean that its acceleration vector points in the opposite direction to its velocity vector. So the acceleration vector at each instant in time for this car points to the left. And we'll assume that it has a constant magnitude. These arrows are all the same length, but they point opposite the direction of the velocity. So for situation C, the velocity is positive. It is slowing down. The speed is getting smaller. So the acceleration points in the negative x direction, opposite to the velocity vector. Okay, now these three last situations are very similar to the first three, except I drew everything going the opposite way. This is to remind us about what coordinate systems mean and what plus and minus signs mean in physics. So my coordinate system is still the same. To the right is positive. And in situation D, this car is moving with constant velocity the whole time. It's not speeding up or slowing down. That means its acceleration is 0. There's no change in the velocity. In situation E, this car is speeding up as it goes to the left. So it starts out with a small velocity. That velocity vector increases in magnitude as time goes on. Velocity vector points to the left in the negative x direction. So that must mean that the acceleration vector also points to the left. The car is speeding up to the left in the negative x direction, so the acceleration vector is also negative. And the last situation, F, car starts out fast, you hit the brakes and it slows down. So it has a large velocity vector to begin with. That velocity vector decreases in magnitude as time goes on. And that means that the acceleration vector points in the opposite direction. The acceleration vector is positive in this coordinate system, points opposite to that velocity vector. So I want to make a table summing up what happens in each of these pictures. Okay, for situation A, we had a car moving at constant velocity to the right. Let's say constant speed to the right. And what I want to do in these columns is just indicate the sign of the velocity vector and the acceleration vector. So for situation A, the velocity vector was positive because the car is going in the positive direction with respect to that coordinate system. The acceleration vector in situation A was 0, so 0 doesn't have a sign. And the speed, what I want to do in this column is to say whether the speed is increasing, decreasing, or staying the same. And here the speed is staying the same. Situation B, the car is speeding up to the right. So let's say the car is moving right and speeding up. Okay, moving to the right and speeding up. That means the velocity vector is positive. It's pointing in the positive x direction. The acceleration vector is also positive. There was our acceleration. Those two vectors point in the same direction, which means that the speed increases. I'll write that out in words. Situation C. The car is still moving to the right, but it's slowing down. Here's where people oftentimes get confused. The velocity is still positive, even though the car is slowing down. The car is still moving to the right. So a lot of times students will get confused and they'll write negative velocity. No, in situation C, the car is still going forward the whole time, just more slowly as time goes on. The acceleration points in the negative x direction. Those two vectors are opposite one another, which means that the speed decreases. So let's do the same thing for the last three situations. In part D, the car moves to the left with constant speed. In our coordinate system, the left direction is negative. So the velocity is negative. Because the velocity is not changing though, acceleration is 0 and the speed stays the same. In situation E, the car is moving to the left. It's getting faster. Now, just because it's getting faster, it doesn't mean velocity or acceleration have to be positive. That all has to do with the coordinate system. The car is still moving to the left, so velocity vector is still negative, and it's speeding up, which means acceleration vector is in the same direction as velocity vector. So both of those are negative. That means the speed increases. And lastly, the car is moving to the left and it's slowing down. The velocity vector is to the left. Because it's slowing down, the acceleration vector is in the opposite direction. So acceleration is positive in this coordinate system where x is positive to the right, and the speed decreases. Okay, so we did all those examples to point out a few facts about the relationship of velocity and acceleration and speed and coordinate directions. The sign of velocity and acceleration have to do with how you choose your coordinate system at the beginning of the problem. In this problem, we defined to the right as being positive, and all these signs are a consequence of how we chose that coordinate system. Speeding up and slowing down has nothing to do with acceleration being positive or negative. Speeding up and slowing down only has to do with the relative signs of the velocity and acceleration vectors. If velocity and acceleration have the same sign, then the speed increases. If velocity and acceleration have opposite signs, then speed decreases. And of course, if acceleration is 0, then speed and velocity are constant.